like it's getting too lengthy, but yeah, I'll try to have like quick demo of like just linear data structure, and probably we can like wrap up this tutorial, and we will meet
Uh,
again probably on Monday or Tuesday, and we can like finish
yes.
non-linear part. Yeah, Vaibhav, were you saying something?
Yeah, I was saying about this link only. Just paste this link in chat box. You already did it.
Okay, perfect. Yeah, so we discussed when it comes to data structure, there means when it comes to programming, two parts: data and procedures. When we try to implement that PK principle, when we try to do combination, again there will be like two things: complex data structure, complex procedure. Data structure will be something that we are studying today. So for linear part, we start with tuples. So tuples is something, as you can see over here. So hash, this thing is like comment, and I have mentioned tuple is immutable one. Okay, so I have defined this tuple with m equal to inside parenthesis 1 comma 2 comma 3 comma 4, and when I print m, you can see uh, over here at first line 1 2 3 4 is being printed, has been printed. So that thing is done. But when I try to, and I'm also able to access that particular zeroth element. So in case of the Python program language, indexing always start with 0 0 1 2 3. Whenever I try to access that particular element m of 0, I would be able to get 1. So am I printing it? Yes. So I should be able to get 1. I'm getting that 1. Okay. But thing is that when I try to change particular element, when I try to replace that 1, when I try to replace this m of 0 with, let's say, 3, and when I try to run this thing, so what I'm saying, I'm using this try except and else command. Okay. So there is like this I guess that's something that we discussed that day, right? Try except loop. So this loop is something we use whenever we have to perform some tests. Okay, so what we are doing over here means I'm not performing any test over here, rather I'm just checking, means I'm trying to just doing this thing, but I don't want this thing to like hinder execution of my code. That's the reason I'm using this try except loop over here. Okay, so I'm trying to store three value at memory location or at like zeroth location of this tuple. Okay, but if it's going well, then it will not go inside this except loop. But if it's not able to execute this thing, then it will go into this except loop, and it will print does not support assignment. So if I print this thing, so you can see it's saying does not support assignment. That means our tuples are like immutable. You can access particular element, but you cannot change particular element. That's all about. And if you, and later on I also printed this em. Okay, so it's again showing 1 2 3 4. It's not showing 3 2 3 4. That means our tuple is not, means this m tuple is not being changed. Okay, you can also check its type using type m. So that's all about tuple, and then there is a list and Python array. So again, it's like finite set of elements, maybe of homogeneous or heterogeneous kind, stored in a contiguous memory locations, and which has sense of indexes. But thing over here is these arrays are immutable. Okay, so this is like huge array that I've created using this length command, length of a. If I type this in length of a inside parenthesis a, means a is array, name of that array. If I type length of a, then I would be able to get number of elements which are present inside this array. So this is something you can check, length of a. So 8 is something you can see over here. 8 is the number of element inside that array. So that's the reason we are seeing like when I type length of a, it's showing like 8. Okay. Then this array or list, it has like some built-in methods attached to it. Okay. So what we are doing, whenever I type a dot append 10, so basically what I'm doing is I'm trying to append this entire list with single element. Okay. A dot append. So it's kind of similar to doing pushing thing in case of the stack operation, or like doing in-queue thing in case of the queue data structure. Okay, so a dot append 10. So 10 will be added after 6. So you can see this over here, 10 is being added over here. I have not printed that thing over there only. Before that, I have also done this adding like new element over here. Okay, so at zeroth memory location, at zeroth index location, I'm trying to add 1000 over there. Okay, so whenever I do this thing in case of the array, it goes well. Wherever in case of the tuple is not working out, that's something help us to understand, like, but arrays are mutable whereas tuples are not mutable. Okay, so it's getting converted from 1 to 1000, and we have like that array as it is. The next thing that we can do is a dot append is something help us to like append our array with like single element. Okay, whenever we do this operation of a dot sort, So a dot sort is something assumes our array to be made of like numeral values, okay, and it will sort that thing in ascending order, and it will save that array again as a only, okay. So no new array or list will be created in that situation. It will save that as same array. So a dot sort will like just take in numerals. It will assume all the inputs which are coming in, which are inside that array are numerals. It will try to sort them in ascending order, and it will store them in same array only, okay. So when I type a dot sort or and print a, I will get this thing only, like 1, 2, 3, 4, 5, 6, 7, 10,000. Okay, so that array is being getting sorted in ascending order. Okay, so a dot sort is something you should keep in mind. These are like really important instruction or command, I would say. If you are doing like Python programming language, you should keep them in mind. A dot append, a dot sort, a dot reverse. So basically, a dot reverse will something will like do like first sort and like means whatever array is there, so it will try to put it in like reverse order, okay. So it will not do ascending descending thing, sorting thing, rather it will just put it in like reverse order, okay. So if somebody asks you to like put particular array in descending order, first run this sort operation and then run this reverse operation, you would get like that particular array put in descending order. Then there is a 2, 3, 4, okay. So z is like I am creating new array z, and if I have to append that thing, so means that becomes quite means difficult, okay. Just see by yourself what exactly is happening. So whenever I am trying to add 2, 3, 4 as it is over here, so that will be added as a one element only, okay, when I use append instruction. So basically what does it mean is, like whenever I'm using append instruction, that is then in that situation our method is considering that whatever element that you are providing as input as a one single element only, and that single element will be added over there, okay. But when I use extend instruction over there, then I'm able to extend my array with like number of elements which are I'm having inside this new element, okay. So if I do a dot append, then this z will be added as like one thing only. But when I do a dot extend, so in that situation 2 will be added separately, 3 will be added separately, 4 will be added separately. So basically what's happening is like this z will be getting converted into iterator, and then at each instant one element is being provided, okay. So that's the difference between append and extend. So append is something which takes in like entire thing and it will store as a one element only, where extend will like can do extension thing, okay, can add multiple things over there, okay. Then a dot copy will like create copy of that array, then a dot insert will add this 10,000 value at 0th location. So this is again similar to pushing or equine. A dot insert 0th location 10,000 value, or a dot pop 0, so it will something will remove this thing from this location, okay.
Mayur,
Yeah,
one question. Now we are talking about array, right?
yeah, array.
So can we add tuple in array, like just with curly brackets? Is it possible?
Yeah, we can put that as one element probably.
Okay. Yes.
Probably that will not work. I believe that will not work.
It will not work.
Yeah, it will not work because that is not a primitive data type.
Yes. So it should be similar if you want to insert it.
Yeah.
Okay. Yeah. Thank you.
Then there is a dot count, so that something will come. That's true. So then a dot pop. So a dot pop will something remove element at 0th location. So it's kind of similar to that queuing thing. Okay, so a dot means over here you can do all the operation related to stack and queue. Okay. So if you change it to like end location, then that will be considered as a stack. That is a FIFO thing. Sorry, LIFO thing. If you consider that to be 0, that will be considered as a FIFO thing. That will be considered like dequeuing from that particular queue. Okay. Then accessing thing from that particular array, you can store it in Z. You can like change that particular element, that's possible. If you have to clear entire array, that's also possible. And then there is one more thing. So C is if I'm storing this string Mayur into variable C, and if I have to get this thing sorted, okay. When it comes to numeral, we can use a dot sort, okay. But when it comes to string, and if you have to sort them in ascending, alphabetical order, so in that situation, we can use this command sorted, okay. And we need to provide that earlier string as a argument, and new string will be generated, and that's something we can store in a B, okay. So this sort is something we use for numerals. Sorted is something we can use for strings, okay. And in case of the sorted, new list will be generated, okay. This is not case with like this just simple sort operation. Okay, so this is like tuples, and I'm just trying to show you that thing stuff like which is immutable and unmutable. So you can see over here, I'm taking the string and it's getting being arranged in alphabetical order. Okay, so that's all about list and tuples. In case of the set and dictionaries, as we discussed it last time, so set is a collection of elements where all the elements are unique. So 1, 2, 3, 4, 5, 4, 5. So here 4, 5 are being repeated. Whenever I type n, so that's something we'll say like class to be set. Whenever I try to print n, so since it is a set, so it will try to skip those elements which are being repeated, and it will just give like unique set. Okay, 1, 2, 3, 4, 5. So that's all about set, and we are putting them into curly brackets. So that's about set, and then there is a dictionary. So dictionary is something where we have like unique set of keys, and we need to put these keys inside this inverted commas, and then after colon we need to put like value. It could be numeral, it could be string, it could be boolean or anything. Okay, so that's something I'm putting over here, and I can get type to be dict. So dictionary is something I'm like, and I can also create new dictionary using this keyword. And whenever I try to type like NN is like name of this dictionary. When I try to so thing is that when in the case of the arrays, when you have to access particular element, we try to provide index as a input over there, right? Over here, instead of index, we try to use key as a index, key as like argument over here. Okay, so what I'm saying is from that NN dictionary, give me a value for a key name. When I type this thing, that NN will give me like Mayur name. Okay, so Mayur over here. And whenever I have to add new key to that dictionary, I just need to like define it that way, like NN, then key, job, and then like my title. And then if I print that thing, then it will print like new dictionary, and that new key will be added. Okay, so that's all about this stuff. Okay. Then next thing is a linked list. Okay, we will just do linked list, stack and queue, and we will like wrap up this session. Okay, I'm also about to like losing my energy. I'm about to lose my entire energy. Oh, that was fine. Okay, so we have like linked list. Guys, are you there? Yeah.
Yes,
So,
yes, yes.
yeah, so in case of the linked list, what we have since we have two things for each node. Okay, for each element, we have like two things. First is the value, and second is a pointer to the next element, which is pointing to the next element. So thing is that whenever we have to define linked list, so in that situation, what we need to do first is we need to define two different classes. So first class is something will generate individual element, and second class will develop skeleton for that linked list, develop skeleton for that linked list. Okay, so using this class node, what I'm doing is, so this first method is constructor. Using this thing, I'm creating this one node. So as I mentioned, in case of the each node or element, there are two things. So self.data, so basically it's value attached to that, so that's something I need to provide. And self.next, so basically this is a pointer to the next location. So using this class node object and define in self data, self.data, data, self.next, none. So basically I'm creating one node. Okay, means I'm creating class which will allow me to create number of node of similar kind. So that's something I need to create. So now I know how to create individual element. The next thing is I need to create skeleton for linked list. Okay, so first again over here, what I need to do is I need to define one method by default which will decide what is the starting location of our that linked list. Okay, so that's something. In case of the key, we consider that as a head. In case of the like the stack, means that's something we consider as like bottom. Okay, uh, so what we do, so that's how this thing will be means that's how we can do this linked list. Okay, and the thing that you see inside this print list method, so that something is only needed when we have to print this tag, print this linked list. But means just this one method and this class is something okay to define this particular linked list. Okay, so even if I like this comment out this thing, it will still work. So I just need to provide head thing over there, and then I need to create instance of these classes, and out of that my linked list will be generated. The first thing that I need to do is I need to the first thing I need to mention where is head for my particular data structure. So that's something I'm creating using this linked list, and that's something creating head is nowhere, means null. So that's how this linked list is being created. And so whenever we have to create any particular instance, what we do, we use this class name, and whatever thing inside that particular construction, that's something we put over here, and that's how that particular object will be created. Okay, so here list is object is now created, and that something will be considered like skeleton of linked list. Next thing that I need to do is, so I have defined where exactly head is. Okay, so what I need to do next is I need to attach my first node to that head location. Okay, so that's something I'm doing. I'm attaching node 1 to that head location. So for LLST, I have head, and so what I'm saying is that node 1. So basically what I'm saying is like data to be 1. So one value will be taken in as a data, and based on that data, this node will be created, and that will be considered as first node. So what I'm doing is I'm creating node and I'm storing that as a head of that particular stack. Okay, sorry, linked list. So this is a basically linked list. It has like two things only, like this data and pointer to the next location. But thing is that first of all we need to define where is the head for that particular linked list. The next thing that we need to and for that purpose we need some element over there. Okay, so using this linked list we get head, then list head equal to this node 1. We try to create one first element over there. The next thing is we try to create two more elements over here. Okay, so here I'm just defining two more elements. Second is equal to node 2 and third is equal to node 3. So basically I'm creating two individual nodes, second and third. Okay, the next thing that I have to do is what we say in case of the linked list, we have data and pointer to the next location. Here I know where exactly start, and these are like two individual nodes. Okay, so what I have to do next is like I need to develop linkage between these nodes. Okay, so what I'm doing next is list dot head dot next equal to second. So I'm pointing first. So over here I have this thing right inside that node, next thing which is pointed to none. So what I'm saying now, point this thing to second element and then point second element pointer to the third element. Okay, so that way first node will be connected to second node and second node will be connected to third node, and that's how my linked list will be created. That's how my list will be created. And when I print this thing, you can see 1 2 3. Okay, so basically what I'm doing, and so basically I'm implementing this method. So what I'm having over here is I'm just checking self dot head means does there does head exist for this particular linked list self dot head. So I'm just checking whether it's there or not. If it's there, then I'm storing it in temporary variable, and I'm checking if does head exist there or not. Okay, if yes, then I will go inside this while, and as long as head exists over there, or as long as this, because this temp variable will keep on changing as long as I'm going to next node. Okay, so what it's saying, as long as this node exists over there, print temp data. Okay, so whatever data associated with that particular node, print that thing. Okay, so first it's checking whether head exists or not, then again it's going further and checking whether node exists or not, because here we are is temp equal to temp dot next, so pointing to next node. And once we are inside that thing, we are saying whenever you are inside that particular node, you are saying like print data associated with that particular node, temp dot data. And that's how that thing is getting printed, and like 1 2 3, because we added 1 2 and 3. So that's how our linked list is being created. Okay, so we don't have like any default definition for this linked list, but that's how this thing is being created. So this is a linked list, and then we have stack and queue. Okay, so guys, I believe like we are already into this session since too long. So stack, queue, then trees and queue, this binary search tree, then hashing, hash maps and graphs. So this is something we will cover on Monday. Okay, I believe this tuple, then this arrays, then this linked list is something clear to you, and set dictionary is also clear to you. And other part like stack, queues, and then graphs, hash maps, heaps is something we will see on Monday. Vaibhav, Kripanshu, do you have any question related to this thing until this point, until stack?
Yeah. Yeah, it's clear. Like linked list is, I have some doubts, but I'll just look again in the video, then I'll get back to you. Like right now, it's difficult to understand.
Perfect, perfect. Yeah. Even if you like don't consider this thing, this function over here, means then without that it's like quite simple. One class for node, one class for skeleton, just to mention where is the head. Then create that head first, and then point it to like first node. Then create two more node, 2 3, and then point first node to second and second node to third, and that's how our node will get created. But yeah, that's all about this linked list. And using this linked list and array, we can create stack. Okay, so you will see explanation for this thing. That's how we can create stack, pushing, popping operation. And using same thing, you can also develop queues. Okay, But yeah, that's something we can see on Monday. Yeah, I want to complete this session on time. That's the reason I'm like trying to rush. Okay, but yeah, thanks a lot for your time. If you have any doubts later on, just let me know.